The base angles of an isosceles triangle are 8 degrees less than 3 times the vertex angle. Just to clarify the problem, I'm going to put the word each here. So the base angles of an isosceles triangle are each 8 degrees less than 3 times the vertex angle. So we will draw an isosceles triangle, 2 congruent base angles, 1 odd man out being the vertex angle. The base angles are 8 degrees less than 3 times the vertex angle. Since the vertex angle comes at the end of the sentence, I will call that x. And translating 8 degrees less than 3 times x, we would translate that as 3x minus 8. And since the base angles of an isosceles triangle are congruent, you can put the 3x minus 8 in both spots. We're talking about the angles of a triangle, so all 3 angles of the triangle add up to 180. Notice we're talking about angles and not sides, so we're allowed to do this. So now we have 3x, 3x, and x, giving us 7x, negative 8, and negative 8, giving us negative 16. Adding 16 on both sides of the equation, we get 7x equals 196. And dividing by 7, we get x is 28. We were asked to find the measure of each angle of the triangle. So the vertex angle was just x. So that is 28 degrees. And the base angles are each 3 times 28 minus 8. 3 times 28 is 84 minus 8, which is 76. So the base angles are each 76, and the vertex angle is 28. Next question, number 7. Triangle ABC is an isosceles triangle with angle A congruent to angle B. So we're going to draw that. So there's triangle ABC. They told us it's isosceles, but angle A, so one swoosh on A, is congruent to angle B. I would stop reading and try to mark this diagram as much as we can. If angle A and B are equal, angle C is the vertex angle, is the odd man out. So it doesn't look like the normal isosceles triangle, it's really on its side. So if we have 2 equal angles, across from those equal angles, we will find the equal sides. It's like they're eyeballs and they're looking at the equal side. So across from A is side BC, so we'll put a dash on BC. And across from the other equal angle B is AC. So we now know that side AC is congruent to side BC. We know AB is 9x minus 1. That's a side length since it's 2 letters, and I'm putting it outside the triangle. BC is 5x minus 0.5, and AC is 4x plus 1. Since we have the dash on BC and the dash on AC, 4x plus 1 is equal to 5x minus 0.5, and that's how we can set up an equation. So subtracting 4x from both sides, we get 1 equals x minus 0.5, and adding 0.5 to both sides, x is equal to 1.5. The most common mistake with this question is that many of you thought that you could add up all 3 sides and set them equal to 180. That's incorrect, because these are sides and not angles. Sides of a triangle do not need to add up to 180, only the angles do. Now the question also asks us to find the value of side AB. Well, AB is 9x minus 1, and we now have an x value. And so we now can plug in 1.5 in for x. 9 times 1.5 is 13.5, minus 1, 12.5. That is the final answer to the question. So the final answer is 12.5. Number 8. It says in the accompanying diagram, we have triangle ABC and ABD are both isosceles, with the measure of angle CAB being 50 and the measure of angle BDA, which is 55, and both of those things are labeled. First information that we need to label is AB is congruent to AC, so I'll put a dash on both of those. And again, that's an isosceles triangle, so not only does it have two equal sides, but it also has two equal angles. The angry eyebrows are looking at the equal angles. So they're across in the triangle. So if we just use triangle CAB for a minute, angle C and angle CBA are congruent. So the 50 degrees is actually the odd man out in this triangle. So we can get each of the green angles that are labeled. So we can take the 180 degrees being in a whole triangle, minus 50, which is 130. And 130 has to be split evenly amongst the two angles, so we're going to divide by 2, and we get 65. So each of these angles is 65. Now, we can also use this information. AB, which already has one dash on it, is congruent to BD. So now we're going to use the bottom triangle, kind of ignoring the top. And now we know across from the equal sides we will find equal angles. And notice we already know that angle D is 55. So angle DAB is also 55 since they are equal. And this time, angle BDA is the odd man out. And I'm going to put 3 swooshes on him. 3 swooshes because he's not necessarily equal to the 50. So notice we can add up the two angles that we know in the blue triangle, 55 plus 55, and you get 110. And now we want to get that vertex angle. So we're going to take 180, subtract 110, and we get 70. So this angle is 70. Last but not least, we have to answer the question. They want us to find the measure of angle CBD, which is the wide mouth angle. It's taking the 65, and I'll actually do this in a different color or a different pen. It's taking the 65 and the 70 and putting them together. So to find the measure of angle CBD, we will add 65 and 70 together, and as our final answer, 135 degrees. Number 9 says, Gus says if a triangle is an obtuse triangle, then it cannot also be an isosceles triangle. It says, using a diagram, show that Gus is incorrect and indicate the measures of all the angles and sides to justify your answer. Well, let's start off with trying to figure out a triangle that goes against what Gus is saying. So Gus is saying, all right, if we start off with an obtuse triangle, it can't be isosceles. So here's a triangle, and this looks like an obtuse angle to me. I want to put 2 swooshes on it, and you'll see why in a second. And I'm going to pick an angle measurement that's obtuse. So for example, 100. All right. Now, let's pretend for a minute this was an isosceles triangle. So these two base angles are equal. I think we could actually find them. The sum of the angles of a triangle is 180. If we subtract the 100 that we already have, we would get 80. And 80 degrees is split up amongst 2 equal angles, so we'll divide by 2. And each of the base angles is 40. So guess what? This triangle is isosceles since it has 2 equal angles, and therefore must have 2 equal sides. And so Gus is wrong. This is a triangle that is both obtuse and isosceles. It also says to indicate the measures of the sides. So the sides don't have to add up to 180. So I'm going to pick a number. I'll call this side 10, for example. Therefore, this side is 10, and the base has to just be different. The base could be 12. Okay? And we also need to justify our answer, which means we need to write a little statement. Gus is incorrect because a triangle can be obtuse and isosceles. For example, The triangle on the left has an obtuse angle of 100 degrees and two equal angles of 40 degrees, making it both obtuse and isosceles. And you can write that in many different ways. I think that would do, but there are definitely different ways to write that. And last but not least, it says that the measures of the angles of a triangle are represented by 2x, 3x minus 15, and 7x plus 15. The triangle is one of these four choices. So we're going to draw a triangle. And again, this time they've given us the angle. So these measurements, or expressions, can go in the mouths of the angle. So 2x, notice I'm writing it inside the mouth of the angle. 3x minus 15, and 7x plus 15. These are angles, not sides, so we know that all the angles in a triangle add up to 180 degrees. If these were sides, we would not be able to do this. So we combine our like terms, we would get 12x, and negative 15 and the positive 15 cancel each other, so we get 12x is 180. Divide by 12, and x, we divide, 18 divided by 12 goes in once. 60 goes into 12 5 times perfectly. So x is 15, but we need to answer the question. So we have to plug the x back into each angle. So 2 times 15 is 30. So this angle is 30. 3 times 15 minus 15 is also 30. So this angle is 30. So notice we have two equal angles. I'll put a swoosh on both of them. And now we have 7x minus plus 15. 7 times 15 plus 15 turns out to be 120. And I know the triangle does not look like that's 120 degrees, but we didn't know that before we did the problem. So we do have an isosceles triangle, and we do have an obtuse triangle. So this is another example of why Gus is wrong. We can have an obtuse isosceles triangle.